Look at your hands. Turn them over. See the lines, the veins, the geography of a life being lived. You believe you know them. You believe they exist in a moment. A single, solid, unassailable moment called now. That belief is a story you tell yourself. It is the most fundamental, most comforting, and most profound illusion you will ever experience. Because beneath the skin, deeper than the bone, something else is happening. A different kind of time is at work. Or perhaps no time at all. There is a ghost in the machine of the universe. A silent, invisible current that carries everything along, yet it cannot be touched, bottled, or held. We have given it a simple name. We call it time. But what if time does not flow? What if it does not pass? What if it is not a river at all, but a vast, frozen ocean in which we are but a fleeting, shimmering ripple of awareness? This is not a question of poetry. This is a question of physics. And the answer it suggests will not just change how you see the universe. It will change how you see yourself. You live your life by the clock. A tick, a tock. A second passes. A minute is gone. An hour is spent. You organize your existence around this steady, reliable march forward. From the sun's journey across the sky to the digital display on your phone, you have always sought to measure it, to tame it, to make it predictable. You think of a second as a real thing, a solid unit, a piece of existence you can count. 1, 2, 3. This idea, the idea of a steady and universal beat, is a lie. It is a convenient fiction our senses have crafted for survival, a story whispered from one generation to the next. To find the first crack in this illusion, you must look not to a clock but to an atom, a very specific atom, cesium-133. Inside this tiny, impossibly small piece of matter, an electron dances. It jumps between two energy levels, two infinitesimally different states of being. And it does so with a rhythm so fierce, so unyielding. It makes a mockery of all our old ways of counting. It oscillates. It vibrates. It sings a silent, subatomic song. It does this 9,192,631,770 times. And when it has completed that staggering count, we, in our need for order, declare that 1 second has passed. This is the heart of your most accurate clocks. Not a pendulum, not a quartz crystal, a tiny atom vibrating at a frequency dictated by the fundamental laws of the cosmos. It seems like the ultimate truth, the final word in timekeeping, a perfect, unwavering metronome for reality itself. But here is the unsettling truth. This perfect clock is not perfect, not everywhere, not for everyone. Take that cesium atom and lift it just 1 foot higher off the ground, and its song changes. It speeds up, infinitesimally, almost unnoticeably, but undeniably. Its rhythm is not absolute. Its vibration is not universal. The most precise timekeeper ever built tells us that time itself is not constant. It is malleable. It is vulnerable. And that single, strange fact is the thread that unravels everything you thought you knew. The story of this unraveling does not begin with atoms. It begins with something much larger. It begins with the sun. Imagine yourself thousands of years in the past. You stand on a sun-scorched plain. There are no numbers. There are no clocks. There is only the light and the dark, the day and the night, the cycle of survival. Your first clock was a shadow, a stick pushed into the earth. As the sun crawled across the vault of the sky, the shadow crept across the dirt. It was a finger tracing the passage of the day. It was crude, but it was a start. It was the first human attempt to capture the ghost, to give it shape. From shadows on the ground, you turned to water dripping from a vessel, sand pouring through a narrow waist. You created clepsydras and hourglasses, elegant instruments designed to make the invisible flow of time visible. You were trying to bottle the river. But whose river? The water in your clock dripped at a certain rate in the cool of the morning and a slightly different rate in the heat of the noon. The sand in your hourglass was not perfectly uniform. Your local noon was not the same as the noon in the next valley. Time was a local affair, a provincial deity. For centuries, this was enough. Time belonged to the village, to the town square where the clock tower stood. Its chime was the law. Then came the age of gears and springs, the age of exploration. Ships crossed vast oceans, and for them, local time was a disaster. To know your longitude, your place upon the empty sea, you needed to know the time on a ship as it compared to the time back home. You needed a portable, reliable clock, a clock that could withstand the rocking of the waves and the humidity of the air. The greatest minds of an era dedicated themselves to this problem. They built chronometers of breathtaking complexity, intricate ballets of brass and steel, designed to carry a single, precious thing across the world: the correct time. This quest gave birth to a powerful idea, an idea that would dominate science for centuries. It was the vision of a man named Isaac Newton. He was a titan, a lawgiver for the cosmos. He looked at the falling apple and the orbiting moon and declared that they were governed by the same universal rules. And as part of his grand clockwork universe, he proposed a grand clockwork time, a true and mathematical time, he called it, something that, of itself and from its own nature, flows equably without relation to anything external. Think about what that means. Newton's time was a single cosmic river. It flowed at the same rate for everyone and everything in the universe. On Earth, on Mars, in the most distant galaxy. Its beat was absolute. It was the drum major for all of reality. It was God's clock. For 200 years, this was the bedrock of physics. It made sense. It felt right. It matched our deepest intuitions. The past was gone. The future was not yet here. And we all shared a single, universal now. Then, at the dawn of the 20th century, a young clerk in a Swiss patent office began to have strange thoughts. His name was Albert Einstein. He was not a grand professor or a celebrated physicist. He was a dreamer, a conceptual revolutionary. He was the skeptic who dared to question Newton's God. He performed his experiments not in a lab, but in his head. They were thought experiments, journeys of pure imagination. He imagined a train moving at incredible speed. He imagined lightning striking both ends of the train simultaneously. For a person standing on the platform, watching the train go by, the two bolts of lightning are unambiguous. They happen at the same time. But what about for a person on the train? This is where the universe begins to warp. The person on the train is moving toward the lightning strike at the front and away from the lightning strike at the back. Because the speed of light is constant for all observers, a bizarre but experimentally proven fact. The light from the front strike reaches their eyes first. For the person on the train, the two events are not simultaneous. The front is struck first, then the back. Who is right, the person on the platform or the person on the train? Einstein's breathtaking, reality-shattering answer was both. Simultaneity is not absolute. The concept of now is not universal. My now is not necessarily your now. With that single, elegant thought experiment, the great cosmic river of Newton was fractured into a billion, trillion personal streams. Time was no longer a spectator. It was a participant. It was relative. This was the first great paradox. The idea that two people could witness the same events and disagree on the order in which they happened, and both be correct, was an assault on common sense. It violated the deepest logic of our experience. It meant that time was inextricably woven together with space. You could not talk about one without the other. He called this new fabric space-time, and it was not a rigid stage on which the events of the universe unfolded. It was a dynamic, flexible medium. This idea was not just a mathematical trick. It was a new description of reality, and it came with a prophecy. The faster you move through space, the slower you move through time. This was the seed of everything that would follow. The end of certainty. The birth of a stranger, more wonderful, and far more mysterious cosmos. So how does this strange, new reality work? How can time itself bend and stretch? To understand, you must let go of the image of time as a line. Instead, you must see it as a dimension, just as real as length, width, and height. You are always moving. Right now, sitting perfectly still, you are hurtling through the dimension of time at a tremendous rate. All of your motion is dedicated to traveling into the future, second by second. But if you begin to move through space, if you get up and walk, or drive in a car, or fly in a jet, you divert some of that motion. You trade a little bit of your speed through time for speed through space. The universe enforces a cosmic speed limit, the speed of light, through the combined 4 dimensions of space-time. The faster you travel through space, the more you must slow your travel through time. This is not a metaphor. It is a physical law. This effect is called time dilation, and it leads to a category of strangeness that seems pulled from science fiction. Imagine 2 twins. One stays on Earth, while the other boards a starship and travels to a distant star at nearly the speed of light, then turns around and comes back. For the twin on Earth, decades may have passed. They have aged, grown old. But for the astronaut twin, hurtling through space, time has moved like molasses. For them, only a few years may have gone by. They return to Earth to find their sibling is now an old man, while they are still young. They have traveled into the future, not by skipping moments, but by living through them more slowly. This isn't just a thought experiment anymore. We have seen its shadow. We have measured its effect. We sent incredibly precise atomic clocks powered by the hum of cesium atoms, on airplanes that circled the globe. When they landed and were compared to identical clocks that had remained on the ground, the clocks that flew were slightly behind. They had experienced less time. They had aged less. Every time you fly in an airplane, you arrive at your destination a few nanoseconds younger than you would have been if you had stayed home. The effect is minuscule, a ghost of a whisper in the symphony of your life, but it is real. Your GPS system in your car has to account for this very effect. The satellites orbiting high above Earth are moving so fast that their clocks tick slower than ours. If scientists didn't constantly correct for this time dilation, your GPS would become inaccurate by miles within a single day. The evidence is all around you, hidden in the technology you use every day. It is the fingerprint of a warped reality, a confirmation that Newton's steady, universal clock is broken. But this is only the first part of the story. Velocity is not the only thing that commands time to slow down. Something far more fundamental, far more powerful, also has dominion over its flow. Gravity. Einstein's next great leap of imagination, his theory of general relativity, rewrote our understanding of this fundamental force. Gravity, he proposed, is not a mysterious pull between objects. It is a curvature. It is a warping of the fabric of space-time itself. Imagine space-time as a flat, stretched-out rubber sheet. Now, place a heavy object, like the sun, onto that sheet. The sheet curves. It sags. It creates a well, a depression in the fabric of reality. Planets like the Earth are not being pulled by the sun. They're simply following the straightest possible path through that curved space. They are rolling around the edge of the well created by the sun. What you perceive as the force of gravity is just the shape of space-time. And if space is curved, then time must be curved as well. The deeper you're inside a gravitational well, the closer you are to a massive object, the slower time flows. The rule of this unseen world is simple. More gravity means less time. This is why the atomic clock that was lifted a foot off the ground ticked faster. It was slightly farther away from the center of the Earth, in a slightly weaker gravitational field. It was higher up the slope of the space-time well. Time for it was literally flowing at a faster rate than for the clock on the floor. Your head is aging faster than your feet. Let that sink in. The difference is impossibly small, measured in quadrillionths of a second over your entire lifetime. But it is not zero. You're not a single age. You are a gradient of ages stretched across your own body. This gravitational time dilation is also factored into your GPS. The satellites are not only moving fast, they are also in a weaker gravitational field than we are on the surface. This actually has a much larger effect than their velocity. Their clocks tick faster. The two relativistic effects, one from speed, one from gravity, have to be precisely calculated and canceled out for the system to work. We see the proof every day. We rely on it. We navigate our world using these shadows on the wall, these echoes of a reality far stranger than our senses report. Time is not a rigid ruler. It is a stream, and it speeds up and slows down as it meanders through the gravitational landscape of the cosmos. And in some places, that landscape becomes terrifying. In some places, the stream of time slows almost to a stop. Consider a black hole. This is what happens when a massive star dies and its core collapses under its own gravity. It collapses forever, crushing itself into a point of infinite density called a singularity. The gravitational well it creates in space-time is not just a gentle slope. It is a bottomless pit. At a certain distance from this singularity, there is a point of no return, a boundary called the event horizon. At this boundary, the curvature of space-time is so extreme that the escape velocity is greater than the speed of light. Nothing, not even light itself, can escape its grasp. What would happen to time near this monstrous object? If you were to watch from a safe distance as a brave astronaut approached the event horizon, you would see something profoundly strange. As they got closer and closer to the edge, their clock and all their biological processes would appear to you to slow down. Their movements would become languid, their signals stretched out over longer and longer intervals. They would seem to slow and slow and slow until they appeared to freeze entirely at the edge of the horizon, red shifted into invisibility, trapped for an eternity at the brink. But what would the astronaut experience? For them, nothing would seem unusual. Their clock would tick normally. 1 second would feel like 1 second. From their perspective, it is the universe they left behind that has gone mad. Looking back, they would see the entire future history of the cosmos flash before their eyes in an instant. They would cross the event horizon, and then they will be gone from our universe forever. Inside the black hole, space and time swap roles. The direction down toward the singularity becomes as inevitable as the direction forward in time is for us. You can no more stop yourself from hitting the singularity than you can stop yourself from reaching next Tuesday. All paths lead to the end. At the heart of a black hole, at the singularity itself, the laws of physics as we know them break down. The curvature of space-time becomes infinite, and time, as we understand it, ceases to exist. It comes to a stop. Is this the place where the river of time truly ends? Or is it where a new, unknown physics begins? We do not know. The interior of a black hole is a secret the universe keeps from us, locked behind a one-way door of space-time. This warping of reality, this dominion of gravity over the flow of moments, is one side of the coin. It is the story of time on the grandest, most cosmic scale. But there is another story, a story told not in the realm of galaxies and black holes, but in the realm of the impossibly small. It is the world of quantum mechanics. And if you thought relativity was strange, you have not yet peered into the abyss. Because in the quantum world, time may not exist at all. We move now from the world of the very large to the world of the very small. From the graceful curves of space-time to the frenetic, probabilistic dance of subatomic particles. This is the quantum realm, and it operates by a set of rules so counterintuitive, so contrary to our experience, that even the physicists who discovered them called them spooky. Relativity gives us a smooth, flowing, albeit bendable time. Quantum mechanics describes a world that is grainy, uncertain, and fundamentally weird. And when you try to put these two great theories of the 20th century together, they fight. They contradict each other. At the heart of their conflict is the nature of time itself. In the quantum world, things do not have definite properties until you measure them. A particle, like an electron, does not have a specific position. It exists as a wave of probability, a cloud of potential locations. Only when you look at it, when you interact with it, does this cloud collapse and the particle choose a single spot to be. Reality at this level is a shimmering haze of possibilities. So what does this mean for time? physicists have tried to write a quantum equation for the entire universe. One of the most famous attempts is called the Wheeler-DeWitt equation. It is a monstrously complex piece of mathematics that tries to combine quantum mechanics and general relativity. And it has a very strange feature. The variable for time, the letter t that appears in almost every other equation in physics, is completely missing. It vanishes. According to this fundamental equation, at the most basic level, the universe is static. It is a frozen, timeless state. The block universe, as it is sometimes called. Imagine the entire history of the cosmos, from the Big Bang to the final heat death, as a single four-dimensional object. Every moment that has ever been and ever will be exists simultaneously, laid out like frames on a reel of film. The past is not gone. The future is not unwritten. They are simply different regions of this block of space-time. If this is true, then the flow of time, the feeling of moving from one moment to the next, is an illusion. A profound and convincing one, but an illusion nonetheless. This violates our most cherished notions. It seems to destroy the idea of cause and effect. If the future already exists, what is the point of making a choice? What happens to free will? If the past is still there, what does it mean to remember something? The classical laws of cause and effect, where A must happen before B, seem to dissolve in this picture. In the block universe, A and B simply are existing in their fixed locations in space-time. The relationship we call causality might just be the way our minds read the story written on the block. We can only read it in one direction. This leads to the deepest and most troubling question of all. If the fundamental reality is timeless, why do we experience time at all? Where does the arrow of time come from? Why do we remember the past, but not the future? This brings us to the role of the observer. For centuries, science tried to remove the observer from the experiment, to be objective. But quantum mechanics dragged the observer back in, kicking and screaming. The act of measurement, of looking at a system, changes it fundamentally. The cloud of possibility collapses into a single actuality because you observed it. So, could the flow of time itself be a product of consciousness? Are we, the observers, creating the passage of time by the very act of observing the universe? This is a radical and highly speculative idea, but it is one that some physicists and philosophers take seriously. Perhaps our consciousness is a kind of scanner, moving through the static block of space-time and illuminating one frame at a time, creating the illusion of a moving present. We are the projectors, and the now is the beam of light we cast upon the cosmic film. Another powerful idea for explaining the arrow of time comes from a concept called entropy. Entropy is, in simple terms, a measure of disorder. The second law of thermodynamics, one of the most robust laws in all of science, states that the total entropy of a closed system can never decrease. Things tend to move from order to disorder. An egg can easily scramble, but an unscrambled egg never unscrambles itself. A drop of ink in a glass of water will spread out, but a cloud of ink will never spontaneously gather itself back into a single drop. A building crumbles into dust over time. A pile of dust never assembles itself into a building. The universe seems to follow this law. It began in a state of incredibly low entropy, highly ordered and concentrated at the Big Bang. Ever since, it has been expanding, cooling, and becoming more and more disordered. Perhaps the arrow of time is nothing more than the arrow of increasing entropy. The reason we experience time moving forward is simply that we are systems that exist within this inexorable trend toward disorder. The past is the low-entropy state we remember, and the future is the high-entropy state we are heading towards. In this view, time is not fundamental. It is an emergent property, a statistical effect of the universe's journey from order to chaos. So we have two competing, bizarre pictures of time. In the world of the large, it is a flexible river warped by gravity and speed. In the world of the small, it might not exist at all, being either a feature of our consciousness or a shadow of cosmic disorder. Which is it? Is it a river or a frozen block? Is it real or an illusion? The chasm between these two descriptions is the great, unsolved mystery of modern physics. It is the place where our knowledge ends and our deepest philosophical questions begin. Let us bring this cosmic vertigo back down to you, back to your hands, to your thoughts, to the very substance of your being. You are a creature of quantum mechanics. The atoms that make up your body, the electrons firing in your brain, they all obey the strange and probabilistic rules of the quantum world. You are built from the same shimmering haze of possibility that sits at the heart of reality. You are a collection of standing waves, a complex pattern of quantum information, a temporary, stable resonance in the chaotic symphony of the universe. And you are a creature of relativity. You are an object with mass, existing within the gravitational field of the Earth. The clock of your own biology is ticking at a rate determined by your altitude and your velocity. You are stretched across space-time, a four-dimensional being whose head is infinitesimally older than its feet. You are built from ghosts, from particles that have no fixed location, from moments that are not universally shared, from a time that slows and stretches and may not even be real at its deepest level. What does it mean to be a person if the foundation of your reality is so slippery? Think about your past, your first day of school, a conversation you had yesterday. You experience these things as memories, as echoes of events that are finished, gone forever. But if the block universe theory is correct, they're not gone. That moment, that version of you, still exists. It is just in a different location in space-time. Your past self is not a ghost. It is a neighbor in a fourth dimension you cannot see. What about your future? The meal you will eat tomorrow, the person you will be in 10 years, the moment of your death. You experience these as unwritten possibilities. But in the block universe, they too are already there. Written, fixed, existing as surely as the present moment. Does this mean you have no free will? That your choices are an illusion? This is one of the most profound and unsettling implications. Perhaps choice is not the act of creating a future, but the experience of discovering which future was yours all along. You're not writing the story. You're simply reading it line by line. What does real even mean in this context? We tend to believe that only the present moment is real. But relativity demolishes the idea of a universal present. Your now is just a thin slice of space-time, an alien in the Andromeda Galaxy, moving at a certain velocity relative to you, could have a now that corresponds to the year 1800 on Earth. Another alien could have a now that corresponds to the year 2500 on Earth. For them, our past or our future could be their present. All moments are equally real, just experienced from different perspectives. Reality is not a single point in time. Reality is the entire block. This leads us to the final speculative leap, the mystery that connects the quantum world to the world of the mind. Consciousness. You experience a continuous stream of awareness, a flow. But what if this flow is the result of a quantum process in your brain? What if your consciousness is in itself a kind of clock? Some theories propose that consciousness is what happens when the brain performs a kind of quantum computation, that our awareness is tied to the constant process of observation and collapse happening within our own neural structures. In this view, consciousness creates the arrow of time for us, personally. It is the mechanism by which we, as quantum systems, process the timeless information of the block universe and experience it as a sequence of events. We are decoherence events. We are the universe observing itself. And in that act of observation, the illusion of passage is born. The flow of time is the rhythm of thought itself. This is on the wild frontier of science, a place where physics, neuroscience, and philosophy meet in a dark and mysterious wood. There are no easy answers here. There are only deeper, more profound questions. Are you a machine for creating time? Is every conscious being in the universe generating its own personal timeline, its own subjective flow from the static ocean of reality? We began this journey by trying to measure time. with sundials, with water clocks, with the intricate dance of gears and springs. We culminated in the cesium atom, vibrating with a near-perfect rhythm, giving us a definition of the second with breathtaking precision. We thought that by measuring it perfectly, we could understand it. We were wrong. Our journey has led us to a place where our best clocks tell us that time is not constant. Our best theories of gravity tell us that time is warped and bent. And our best theories of the subatomic world suggest that time may not be fundamental at all. We have returned to the central question, the one that haunted the first human who watched a shadow lengthen on the ground. What is time? After all this, after Newton and Einstein, after quantum mechanics and black holes, the answer is not a neat definition. The answer is a reevaluation of the question itself. Perhaps time is not a thing, not a substance that flows, not a dimension to be traveled. Perhaps time is a relationship. It is a relationship between cause and effect. It is a relationship between order and disorder. It is a relationship between you and the universe. It is a measure of change. If nothing ever changed, there would be no time. It is the grammar of reality. It is the structure that allows the story of the cosmos to be told. Without it, there would only be a single, static, meaningless is with it. You can have was and will be you can have process. You can have life. Think of the universe not as a machine, but as a piece of music. The laws of physics are the key and the scale. The particles and forces are the notes. And time? Time is the rhythm. It is the tempo, slowing down near the heavy bass notes of a black hole, speeding up in the empty passages. You cannot isolate the rhythm from the music. You cannot bottle the tempo. It exists only as part of the whole performance. It is the pattern that gives the notes meaning. Your life is a brief, complex melody in this cosmic symphony, a unique and unrepeatable tune. You experience it one note at a time, and this experience is precious precisely because it feels linear, because it feels like it is passing. The illusion, if it is an illusion, is a meaningful one. It is what allows for love, for loss, for growth, for memory. It is what gives value to the moment. The quest to understand time has not given us a final answer. Instead, it has given us a gift. It has replaced a simple, common-sense idea with a profound and beautiful mystery. It has shown us that the familiar world we inhabit is just the surface of a far deeper and stranger ocean. So the next time you look at a clock, the next time you feel a moment slip away, do not think of it as something lost. Think of it as a vibration, a shimmer in the fabric of space-time, a note in a song that has been playing forever. Think of yourself not as a passenger on a river, but as a part of the water itself, a pattern of energy that exists now, and in a way you can't quite grasp, exists always. The mystery is not a problem to be solved. It is a reality to be lived. And the fact that we can even ask the question, that we can use our minds to peel back the layers of the cosmos and gaze into the timeless heart of it all, well, isn't that a wonderful way to spend our time?